Our chapter's name is acid, bases and salt. We will study acids, we will study bases, their properties, but this is very preliminary level. The level that you'll study in 11 will be much more deeper, and then we will study about salts. But our discussion on this chapter first starts with something that is known as a indicator. Indicator. Because if I bring a tumbler full of a liquid, I can't ask you to drink it and taste whether it is acid or base. You need something which will tell me whether it is acid or base. Any school which has started this chapter already? Very good. Phoenix Green has started. Any other school? No. Okay. Oh, your school also started. Okay. Indicator. Indicators. Indicators chemically are known as dyes. You know dyes. You dye cloth. You dye hair. Dyes. Have you seen a hair dye? A hair dye will always have two tubes in it. One is a color and one is a developer. So you actually mix the color and the developer. At that time, it will be milky in color. And once you put it on your hair and you wait for some time, then it will undergo a reaction and it will change into a color. Similarly, we do dyeing for fabrics also we do. So an indicator is a dye which will undergo a chemical reaction. Which will undergo a chemical reaction with, now here is the thing, either an acid or base. Okay, children, this is like a chicken and egg story. You now don't know what is acid and base, so just gulp it. Acid or base or both. So what I'm trying to say here, an indicator is a dye. Let's say dye A. Dye A may react with acid, or it may show no reaction with acid but react with base, or it may react with both. Okay, so either with an acid or a base or both, and show a change in color. And this change of color that it shows with either an acid or a base will always be the same type of color, little bit lighter or little bit more darker, but it won't immediately show a different color. So it becomes a standard instrument or a standard test for you. Like say, I want to test all good people. So I've got an indicator. Whenever I put it in good people's head, the indicator glows blue, very dark blue, light blue, thoda sa less good people, but it will never show red. But that same in magic wand, when I put it on some other people who are not good people, then it shows red. So by now I can understand that as an indicator, and I can use it to test any new person also. And you understand the same logic we use here. So indicators are dyes. What are dyes? Dyes are a class of compounds which show coloration with a chemical reaction. Their only job is to produce colors. Dyes will always show colors when they react with a class of compound. Now indicators are a class of dyes which will react with either an acid or a base, or may react with both. Means it's not that every indicator will react with both. Some indicators may react with both, some indicators may react with only one. But for each reaction with each of these, either acid or base, it will show a particular color. And based on that color, we can use it as a standard tool for testing an unknown chemical, whether the chemical is an acid or a base. I spoke a lot of words. I hope I made some sense. Have you understood what I said? So, given a tumbler full of a liquid, I can't ask you to drink that liquid. You don't know whether it is acid or base. Sir, first of all, tell us what is acid or base. That we will know later. In order to test it, you need some sort of an indicator. So, indicator will be a liquid. I'll take a sample of that liquid from the bucket, take it in a test tube, and I'll take my indicator and I'll just put 1 or 2, 3 drops. There will be a color change. And there are some standard color changes which will actually help me understand that the sample that you brought, was it an acid, was it a base, or was it neutral? Further, we will study if it is an acid, is it a strong acid? If is it a base, is it a weak base, and so and so. Make sense? So we need to study a little bit about indicators. Let's understand some indicators. Okay. Now, in chemics, in laboratory, at a very primitive stage, when we are at a grade 10, grade 11, grade 12, something till your senior secondary level, we deal with 3 types of indicators at most. The first one is known as litmus. The second one is known as methyl orange. Wow. Methyl orange. And the third one is very difficult to spell by the way you pronounce it. The third one is known as, when I pronounce it, is phenolphthalein. What is it? Listen to me. Phenolphthalein. Phenolphthalein. There's a P, phenolphthalein, but when you write it is phenolphthalein. So when you write it, it is phenolphthalein. Phenolphthalein. So there are three of this. We'll understand each one by one. Okay. There are many other things also. Bakul itself is one indicator. You can use him, dip him in something, he'll change color. So he's an indicator. Right? So let's start with litmus. Right? Litmus in the laboratory is available generally as litmus paper strips. Litmus paper. And these litmus paper, initially when you get, they will be like white or pale pinkish in color when you buy it. They're just like your post-it type of notes, the slender ones, which you use on paper. So it is just, you will have litmus strips. So litmus, what it does, litmus paper, if you bring in contact with an acid, right, the litmus paper will turn red. Always remember, red means danger, red means acid. Okay, understood? Now, litmus is in both sides it will work. If you bring it in contact with a base, litmus will become blue in color. Okay, now the interesting thing, if you take this blue litmus paper, which is blue at one end, again dip it in acid, it will turn red. And if you take this red end and you dip it in base, it will again become blue. Is this understood? Litmus is available as litmus solution, and that's why generally everyone says, you know, if you talk to that person, he speaks from his heart, his words are like a litmus test, he won't say anything hanky-panky. There are some people, right? You know how people butter people, like just because my boss's wife has said that this t-shirt I'm wearing is green, I know it is not green, but how can I disagree with boss's wife? My promotion will be held. Yeah, it's not green. I mean, there's some indigos nowadays available, dark blues, a little bit like a peppy green in nature. Those are called diplomatic people. Be very, very careful for them. They're chameleons. In Hindi, we call them thali ka bangan. They'll just roll over on the thali. Whichever is the gradient, they will go there. Yeah, it looks like that. I like that pepper tangy green. I like the pepper green, you know. I like that crunchy yellow. What about crunchy yellow? Yellow is yellow. Right. So litmus paper, litmus is no hanky-panky. Either it will turn red or it will turn blue. And if it doesn't show any action, that means whatever you are testing is neutral. Neutral. Doesn't confirm for water. For water always, cobalt paper, oxide paper is what we use. But it will show you that it is neither acidic nor. Is this understood?
Yes, sir. When you dip it in acid again,
it will turn red. Till that time, huh? It is not a confirmatory test for water. Litmus does not. It can tell you that the acid strength is very less. So if it is a strong acid, the litmus will be showing very dark red, right? And slowly then if you just drop one pinch of base on it, slight bluish you will see forming on it. There are a lot of interesting stories we'll discover one by one, right? Is this clear about litmus? Okay, litmus is available as litmus paper or litmus solution. If you talk more about litmus, then litmus actually comes from a plant which is called lichens. Okay. I'm not getting the phylum of that. It is what data? There is a class of that plant also. Aha. It comes from the plant which is named as lichens. And the solution, when you get it from plants, at that time the neutral color of this solution is actually purple. Litmus will come as purple. So litmus is a form of natural indicator. It's a natural indicator whose extract is taken out, and in the laboratory we process it in the form of strips and we keep it. So sometimes a question may come, what is the natural color of litmus when you get it from lichens? It is actually purple in color. But you don't use it in that form directly. You will be using it only after processing it into a paper or a strip. Yeah. Anyone? Anyone?
In the solution, what color is it?
Neutral.
So only clear. And then if you put acid, it turns.
Or mildly maybe purple. When you put acid, it will immediately become red. And then when you put base, it will turn into equal strength base you have to put. What happens if you? It will still remain blue. What happens when you feed food to a hungry person? He donates, not to a person who has eaten a lot, he donates it. Vakul, if you don't mind, can you take this food packets? You can have it for lunch tomorrow, like that he'll give you. So if you dip a blue litmus on a blue paper on a blue solution, it will stand. This is done. Okay, let's talk about methyl orange. Methyl orange will again become red when it comes in contact with acid, and with base it will be yellow. With a base it will show yellow. Methyl orange is also used, commonly used. Orangish in color. And phenolphthalein, most used for titration. This is neutral in acid, colorless. Neutral means colorless. Colorless when it is in acid. However, when it comes in contact with a base, it will give what is known as a pink color. Just like KMnO4, it will give a pink color.
What's the chemical formula for?
No, these are not chemicals. These are complex products. Dyes, you'll study in 11 something called complex and ligands. These are all ligands. You don't have a direct formula for them. Now you can't ask me what is the chemical formula of mustard oil. You don't have a formula for that. Okay. Clear this much? So here we also talk about something which are called natural indicators also. While these are chemical indicators, we also have a class which are known as natural indicators. One of the most, sorry.
The red one will come, I don't understand. The red one will come in contact with acid.
The third one is known as, I'm pronouncing for you, phenop. Phenop. You pronounce it like this, Bitu. There is no issue. Phenophthalin. This is how you pronounce it. Phenolphthalein. Phenolphthalein, but you write it as phenolphthalein. Okay, phenolphthalein. You spell the word. I'll be more happy. Phenolphthalein.
Now,
Yeah. Tell me.
so, phenolphthalein will come in contact with acid.
Is colorless. Means phenolphthalein itself is colorless. It's absolutely colorless like water. You take in a dropper, few drops of phenolphthalein, and you drop it in a test tube which has HCl in it. There will be no change in color. It's a dye. It's a dye. But if you take 2 drops of phenolphthalein and you just put it in a test tube which is having, say, sodium hydroxide, which is a base, immediately the first drop pours into it, ping, it will come out. Methyl orange, the name itself says. Yeah. So it will become red. That nobody will ask you. They'll ask you methyl orange in contact with acid, reaction with acid will turn red. And the reaction with what you call base will turn it yellow. Okay. Now we talk about some, this is the most interesting part. Natural indicators. Okay. The first one we'll talk is, and see how nice example I'll give. Turmeric. Turmeric. So our friend Shreya now goes to a restaurant, okay, which is near her house, and she has gone in that restaurant, and she is vegetarian by diet, so she has ordered some paneer butter masala. And that being a very nice party day or something, she is wearing a white dress and is having paneer butter masala. Now see how we will behave like fools, though we study chemistry. Now while having paneer butter masala, she spills a little bit of the curry on her dress. Immediately what will you do? Excuse me please, and you will go to the washroom. The first thing you will go to the washroom is, you'll see that hand dispenser soap out there. You'll just pump that, take out some soap, and she puts it on that particular dress. What was curry now will be seen like a blood red stain will come up. Turmeric is a natural indicator of base. 10th class science which the child forgot. What do we write? Turmeric is a natural indicator of base. And the soap that she was using in the soap dispenser, the soap is a base. So she actually brought base and she is rubbing it on turmeric. Turmeric is showing its color. What was pale paneer butter masala will now become burnt red. Like, so the question comes, if when you at your home you're hosting a party and you've got a white dining table cover and people will spill, should you immediately apply water? No. First, should you immediately apply soap? Never, never, never. First, always do water wash. Try to take out as much turmeric as you can. We Indians love turmeric. You know, the nails become yellow, everything becomes yellow. So take out as much water as possible. Then only you should go for a wash. Even if you go for a wash, after the wash it comes out, you'll still see that yellow stain. Now the question arises, sir, but in upclass restaurants, you know, all the napkins and serviettes they give are absolutely white in color, and people eat all these Indian dishes and keep on dabbing their lips. How do they become so pristine clean? They use something called bleach. What do they use? Bleach. A base is a very good bleach. Now, many people don't agree with me, but again, I'll tell you, I can give you photographs also. Have you gone to, say, good class hotels and have you seen their towels? They are absolutely sparkling white. You mean to say they're washing Ganges water? No. Now, how to get that sparkling white towels in your house? You know what I do for my white towels? I'll put them into the washing machine. If your washing machine has got a little bit of heating facility, so you can add some temperature to it. And instead of adding, while I add detergent, I just take that Amazon Presto red color bathroom toilet cleaner is there, right? Red Harpic or the red toilet cleaner. I just put that on the washing machine. I mean, that you use on the toilet. I'm not taking toilet water. I'm taking that liquid and I put it because it's a very strong base. After that, when the towel will be washed, it will be sparkling white. However, the towel being washed with such a strong bleach agent will make it very kurkura. Means if you wash your face, wipe your face, you can get scars on your face. So what you should do, add little bit of softener. You know, softener. In Hyderabad, we have less use of it. If you go to Delhi and cold places, people wear a lot of sweaters and other things. So when you wash sweaters, you use softener. Softener will make the fabric fluffy. And then you see, I have even demoed it to students by washing towels and drying them and clicking pictures. They will be just like lemuridian, you know, absolutely fluffy and white. So hotels also wash their linen, that is the napkins and everything, in strong bleach. Then only that color will go. Otherwise, anything where Indian food has been handled, and then you'll see some children, mama, washing their hair. And if you wash that in detergent, it will never ever remove the stain because it has got turmeric. And once turmeric comes in contact with soap, it will leave a. So next time you spill food on your dress, remember this class. Do rush to the washroom, but don't you ever touch that soap and do this. Once you touch and do this, you're gone.
Doesn't the towel also get stained with color because you're washing it with a base?
No, before that, there's a bleach will be there. Bleach can take away your skin. What is bleach? Bleach is something which will say permanent coloration. Yeah.
So hotels use a strong base as well.
No, their washing powders, detergents that they use, those detergents are very, very strong basic. Or else they will use fabric whitener. Have you heard about something called ala liquid, ALA? It's white colored. You know, if you wear a lot of white shirts to office, like say pilots and crews and others, the water that we get in our house is not that good. So if you wear white shirts, when in my office days, I used to wear a lot of white shirts. If you wear white shirts, you can't maintain that pristine white. It will slowly become off-white, yellowish. That's because of the water. So at that time, you need something called a bleach. Rin, you know, the detergent. Rin has a liquid which is known as Rin Ala, ALA. Once you open it, it will smell like harpicish smell. So when you wash your clothes, along with the detergent, you are supposed to give that ala. That's basically a mild bleach. And your white garment will come out.
Sir?
Yes, sir.
Sir, but if hotels use a strong base, then we use that now, how to not damage us.
No, why will it damage your skin? You're not using the base on your skin. Who has asked you to put the base on your skin?
You use it.
The red harpic. I'm not bathing in that red harpic. I'm washing the towel in that red harpic. End of the day, the towel is so dirty. It has to be cleaned, my dear. How do I clean it? You need a strong bleach. It will bleach it up. And to make it more fluffy and to make it soft, you add some fabric softener. But that again, one more question comes up. This chapter has got a lot of these life skill things. Then I'll teach you one day how to make your toilet pot absolutely sparkling white without even brushing it or without doing anything. But there is a risk factor involved to it. Tried and tested. I used to post this on our TAR forums also. You can apply whatever liquid you want. If the flush water quality is not good, which is in our society, we use the same recycled water. So after a few days, you will always see that your toilet pot gets, it gets stained, scaly. How to remove all those things without doing any work? Plug in your earpods. It's just 2 chemicals, which is readily available. Some precautions to be taken. Enjoy your music for half an hour. Just come and flush it. Sparkling clean. Chemistry is to be used in your daily life with care. So towels, I told you how to clean towels. One student did also last year. White towel, but never ever wash any cloth which has color using that red harpic. Then this t-shirt will lose color and it will put this color on that white garment. Generally, white garments are never to be washed along with colored garments. Sometimes when you buy handloom saris or handloom dupattas, you will see always your mama or somebody, they will always soak it in buckets separately because it will leave color. And with that, if your school uniform has been put, very good. Next day, you will go like a Superman to the school. Understood? So turmeric, remember this, is a natural indicator of base. These sort of natural indicators we have got like red cabbage. Red cabbage is also a natural indicator. Okay, one of the wonderful natural indicator for acid is the flower plant called petunia. Have you heard about petunia? Okay. Now suppose from our friend Anvita's house, I bring a small cutting of petunia, which used to flower, say, yellow in her house. And I bring that and I grow it in my flower pot. It's not guaranteed it will flower yellow. It might flower completely different color. Because petunia is very sensitive to the type of soil. If the soil is more acidic, her flower pot soil may not be the same as mine in terms of chemical composition. My pot might be more basic or more acidic. So the petunias will also show their color. Clear? Hydrangea. Yeah, that's the same thing. Hydrangea will also show the same coloration. Petunias are from the same class of plants. So, and the lovely colors that petunias show you, if you go and see petunias, they will have different colors. All that you can play with. Just increase the acidity. Okay, now somebody will ask me, sir, how do I increase acidity of soil? Add more of compost. Anything like cow dung or organic compost. Organic compost, whichever you have created from your house. The more compost you add, the more solid acidic it will be. Sometimes you have increased the acidity so much, then you need calcium carbonate. What to do? Every morning my mama makes omelette. I ask her to save the eggshells, dry them, then grind them in the mixer grinder and put it on the flower plot. Again, the acidity will come down. Those are the richest source of calcium carbonate. Okay? Turmeric, red cabbage, litmus, these are all called natural indicators. Another class of indicators that we use are called olfactory indicators. Olfactory, lovely little word. Olfactory indicators. Now, these are very interesting. The year goes back to 2020, when for 2 years you never went to school, right? Because it was all COVID. So what is the first symptom of COVID? Fever. And how do you fever say? There's something more that used to happen, that used to know that you have COVID. You forgot, you were kids. You will be asked to open one bottle of Vicks Vaporub or Iodex and smell it. If you can't smell it, that means you have lost your smelling capacity. And smelling capacity lost with fever, the first thing that is to strike us, COVID to nahi hua. So, because Vicks you can smell every time, Vicks Vaporub, During peak COVID, even if you are frying, say, garlic and ginger garlic paste has a very strong smell. You can't smell it. So we used to say that Ananya is olfactorily muted. Muted. What is mute? Mute means volume cut off. Her olfactory sensors has been muted. Means now she can't smell. It used to happen in COVID. Smelling power is to be lost. So olfactory indicators means those indicators which will use the smell. So one of them is onion and another is vanilla. Onion and vanilla both have a very distinct smell. You know that? An onion a day keeps everyone away. After your lunch, chew some onions along with the biryani and then talk to everyone with a big personal space, because every time you open your onion is so strong that if you have lots of raw onion slices with biryani in the dinner and get up tomorrow morning till 8 o'clock, if you burp, it will be onion smell. So onion is known as a natural indicator. Got it? Similarly is vanilla. Vanilla has a very strong smell. Open a vanilla, vanilla essence, the small bottle that we use for making cakes. Just they say that when you make vanilla cakes or vanilla ice cream, zyada nahi, only 2 drops. Because if you add more vanilla, yeah, right, it will become bitter. Now these two fellows do not for both, lose smell when in contact with acid. Now go to a lovely Indian restaurants, you are served those small round onions which are dipped in vinegar. Vinegar is what? Acetic acid. Do you lose the onion taste? No, you don't lose the onion taste. So onion and vanilla, if you pour 2-3 drops of acid on them, their smell is not lost. They have a distinct smell. You know that, right? If you have stored onion in any steel container in a refrigerator, always close it. Otherwise, the entire refrigerator will smell onion. And never ever store bananas in a refrigerator. If you have done that idiotic task, the whole refrigerator will smell like banana. Okay? So onions do not lose. However, their characteristic, oh, my English is bad, their characteristic smell is lost when in contact with a base. Arey, simple knowledge here. A katora or a bowl which was kept for storing slices of onion, can you water wash and kill the smell? No, you will be using Pril or Vim. What is that? Base. So when you clean or you pour base on vanilla or you pour base on onions, they lose their characteristic smell. Is this clear? So understood? Onion and vanilla, they are known as olfactory indicators. So somebody might ask you, what are olfactory indicators? Olfactory indicators are indicators which have got a distinct smell. And why are they called an indicator? Because that smell might be retained when in contact with a particular class of compound. But when it comes in contact with another class of compound, that smell might be completely lost. Children, give me some example. Well, the examples are onion and vanilla. They have a characteristic smell, and this smell is completely lost when in contact with a base. And if you forget that, always remember an onion dish is always cleaned with Vim bar so that there is no smell. Right? Chale aage. This is all about indicators. Any questions here? So you learned about 3 indicators: litmus, methyl orange, phenolphthalein. While litmus and methyl orange show in both, phenolphthalein will only show in base. Has got a distinct pink color. The other 2 have got red. And in Hindi we say litmus to remember. Why not now? Later. Because I need to teach you something, then only it will become more interesting. Okay. Let's go further now and enter into the zone of something which is known as acids. And we'll go very slow. Acid. There are a lot of definitions of acid. The first definition of acid that we study is known as the Bronsted-Lowry concept of acid. This is names you'll get in grade 11. So, and then there is, what is his name? Arey, the guy who did not vote Mendeleev in periodic table. Arrhenius. The one that we study in grade 10 is known as the Arrhenius definition. Arrhenius is a scientist name. Arrhenius, though the name is not there in your textbook. What you study is the Arrhenius definition of acid. Everyone has defined acid according to their liking. So Arrhenius says, or in grade 10, we will say, to understand acid is a compound. Acid is a compound that releases H plus ions in an aqueous solution. If a compound has the ability to release H plus ions, this is Arrhenius concept, okay? H plus. So H plus is again very interesting. Look at the hydrogen atom. The hydrogen atom has one proton and one electron, right? Hydrogen atom has one proton and one electron. What is H plus? Kidnap. What is H plus? In H plus, it will go back to the same previous one. Okay, 1 minute, huh? 1 minute. So this is my hydrogen atom. Hydrogen atom has got a proton and an electron. When you talk about H plus means the electron has been kidnapped. So the orbit has also gone. So what you are left with in case of an hydrogen ion is nothing but a hydrogen ion is nothing but a proton. A hydrogen ion is a proton. Because hydrogen atom has got one electron and one proton. If the electron is lost, then only the proton remains. That's why any process in which acid manufacture or acid creation happens is known as protonation. Not in CBSE, but you should know because in 11 you will deal with this word. Protonation. Protonation process means you are starting a process for release of H plus, right? And acid is a substance which releases H plus, which can also be understood that it releases protons. This is the Arrhenius concept. Arrhenius name is not in your syllabus. When you go to grade 11, you'll study about another concept called the Bronsted-Lowry concept. They say acid is a substance which accepts an electron. Somebody who releases a proton will accept an electron. I release a proton. I don't like plus guys. That means I must be liking minus guys, right? It will release. We'll see that why it releases an H plus. It has to. So in our grade 10, we will study acids are compounds that releases H plus ions in aqueous solution. Now, what is an aqueous solution? In an aqueous solution, you will have water molecules. Do you agree? Water is a neutral molecule. When you have released an H plus with this water, it creates another ion which is known as the hydronium ion, H3O plus. Did you understand what is the formation? You had two hydrogen, one hydrogen added, but the hydrogen came with a bindi on it. So the neutral nature became to one positive. This is known as hydronium ion. And from here, we will change our definition a bit. Acids are substances that release either H plus or H3O plus ions in an aqueous solution. Hydrogen ions or hydronium ions. So what does an acid release? An acid releases H plus. That H plus will be released always in the aqueous medium. The aqueous medium has got a water. It reacts with the water molecule, forms H3O plus. So in chemical reactions, when they will say acidified environment, they will always write like this: H plus, H3O plus. This means what? Acidic environment. The reaction is happening in acidic environment.
Why does it react with H plus? Isn't it already stable?
No, not stable. Nothing is stable. Water is a polar compound. Then you will study. That's why the chemistry of CBSE is very weak. Water has got, how do you say? I share a pack of sketch pen with you. But who keeps it at his or her house? The dominant fellow. Ananya, whenever you want, you take the sketch pens, right? We will share it. But it stays at whose house? My house. Who has more control? I have more control. It's like that. So that is called electronegative nature. Oxygen has got some extra electrons which do not take pair. Those electrons are like a girl getting married in a house which has husband's sister also who is not married. That sister will create her life as a hell. Those electrons are like that. They are called lone pair. So they will pull other electrons and make it non-neutral. Those are beyond your level now. So you just understand H plus reacts with H2O to create H3O plus. Is this much understood? Okay. So what is an acid? An acid is a compound that releases an H plus or an H3O plus in an aqueous environment, always an aqueous solution. Well, how is H3O plus obtained? Sir, H plus reacts with the H2O to produce H3O plus. H3O plus's name is known as hydronium ion, and this is hydrogen ion. So to define acidity, if you say, sir, he releases only H3O plus, he's an acid. Sir, he releases H plus, he's also an acid. Sir, he releases both, he's also an acid. Okay, clear? Our next topic of discussion would be organic acid versus mineral acids. Okay. What is organic, sir? Everything that we eat is organic. Organic comes from the word name, anything that is living. And living can be always from what? Either the flora or the fauna. In Hindi, we call it Jaivik, जिसमें जीवन है, the one which has got life in it. Acids which are present in organic matter. What are organic matter? Matter that is derived from living world of flora and fauna. These acids will be known as organic acids. If you slice a lemon, which is flora, you get citric acid. Milk, you will be getting something which is known as lactic acid. Similarly, in fruits, you will get malic acid, like all the tartaric acid. Okay, so all these acids are known as organic acid. Nobody will ask you so much of names, but you should know just few of them: citric acid, lactic acid, then malic acid. These acids are obtained from where? They are obtained from organic substances, so they are called organic acids. And acids which are obtained from minerals, that is generally from minerals undergoing reactions and then forming chemicals, those acids will be known as mineral acids. And these are the sulfuric acids, the nitric acids, the hydrochloric acid. Now this one has an issue. Hydrochloric acid is also produced in your stomach also. So HCl can behave both as an organic acid, also it can behave as a mineral acid. हमारे पेट में जो acid है, that is hydrochloric acid. So HCl belongs to both family. If you're producing it in a lab, then it's a mineral acid. Then some other acids, if you want to know, like phosphoric acid, H3PO4, enough.
Is acetic acid and organic?
That we will see now. So do you understand the difference between organic acids and mineral acids? Acids which are derived from minerals, means minerals will undergo a lot of chemical processes. From minerals we get compounds. From those compounds we will have a lot of processes, and from those processes we will be getting some acids. Those are known as mineral acids. And organic acids are always obtained from organic matter. This is one class of division. Another class of division is strong and weak acid. Now this is very, children majorly goof up in this. Strong acid and weak acid. Why they goof up? They think that these are strong, these are weak. ऐसा नहीं है. This is a complete different classification. This is a complete different classification. Usually all mineral acids are strong acids, with an exception of an acid named as carbonic acid, the one which is there in your Pepsi or Coke, H2CO3. Carbonic acid is a mineral acid, but this acid is weak. Means you can drink it, no issues. Agreed? And all natural acids, that is the organic acids, are always weak acids, except the one that is there in your stomach, hydrochloric acid.
There is no H2CO3 is A weak acid?
Yeah, it's a weak acid. You drink it in Coke and Pepsi, but it is a mineral acid. It's a mineral. Usually mineral acid means the danger icon should be associated with it. Any mineral acid has a danger icon associated with it. Acetic acids are also organic acids because they are made from organic compounds. Now these organic, when I'm saying organic acids are sourced from living plant or animals. However, every organic compound can also be synthesized in the laboratory. Right? When Woolmer made urea for the first time, that was when we said that yes, organic things can be made. So all organic acids, as you see, now you can tell me, sir, what are organic acids? Acetic acid, methanoic acid, right? Then have you heard about something called boric? Boric is a powder. In our days, when we used to play carom, we never had decathlon and all. We used to go to a pharmacy and buy boric powder. And boric powder is best for playing carom. It's very, very smooth, but it's actually an acid. People who have fungal infection or skin marks, they use, and it will be sold in the laboratory as and in the pharmacy as boric acid. Have you seen medicines? Next time you see a medicine, the medicine is always written like this. Siko, some general knowledge. Boric acid IP. If you buy Dolo, you will always say Dolo 650 IP. Do you know what does IP stand for? Indian Pharmacopoeia. The drug is made in accordance to Indian Pharmacopoeia. Some very costly drugs will also have BP written with them. British Pharmacopoeia. Every medicine will have an IP written with it. Just go to any medicine and see. It will have an IP name. So boric is boric acid. Organic acids are usually you'll see them in solid form. Salicylic acid, one of the common acid used for any sort of skin infection. Like you have got acne coming out, it is always treated with salicylic acid. And lactic acid. Both, a mixture is available. All these acne clear creams which you see, in 3 days my acne gone. College freshers, what do I do? So all those have got something called lactic acid and salicylic acid. The moment you put it on your acne, you'll feel heat. Organic acids, and they are all weak. That's why you're able to put it on your face. You can't take sulfuric acid tomorrow. Freshman, MUN, I need to look good. Take a pinch of sulfuric acid. Oh, my face is gone. You can't do that, right? Understood? So you're gonna get a difference now between. We have not discussed about strong and weak. There's a complete different definition which we will take in our next class. For today, just understand. Never have the assumption that this is weak and this is strong. No, not like that. This is a complete different class of comparison. However, when you compare this class, here you can tag. Usually this family is always weak. This family is always strong, barring this fellow. And this family is weak, barring this fellow. This fellow, when it is coming from your stomach acid is very strong. Small pins and all, it can immediately corrode. Nullify it. So next class we'll be talking about strong acids and weak acids before we go on to acid properties and reactions, right? Close our class today. Thank you then.